Hey guys, welcome to my YouTube channel. We are going to be looking at waves. We'll mainly focus on sound. Sound is a mechanical wave, it is a longitudinal wave, it is a pressure wave. Okay, now what is a mechanical wave? We can categorize waves based on their ability to transmit energy through vacuum. We can divide them into two waves, electromagnetic waves and mechanical waves. Electromagnetic waves are produced by charged particles and are capable of transmitting their energy through vacuum. An example of an electromagnetic wave is a light. The sun produces electromagnetic waves which reach the earth from space, which is vacuum. So the electromagnetic waves have the speed of light, which is C equals 3 multiplied by 10 power 8 meters per second. So the speed of light is denoted by C. Now mechanical waves. It requires a medium to transfer its energy from one location to another. It is not capable of transmitting its energy through vacuum. A few examples of mechanical waves are sound waves and Mexican stadium waves. Okay, as you can see here, only the charged particles are moving through vacuum, but the mechanical waves need a medium to transfer its energy, and the particles collide with each other with force to transfer the energy. So what is a longitudinal wave? We can also categorize waves depending on the direction of the motion of the particles. They are divided into transverse waves and longitudinal waves. So the particles in transverse waves move perpendicular to the motion of the wave. A few examples of transverse waves are ripples on the surface of water and Mexican stadium wave. They require a relatively rigid medium in order to transmit their energy, which means they cannot transmit their energy through liquids and gases because the particles slide over each other. In longitudinal waves, the particles of the medium move in a direction parallel to the direction that the wave moves, which means the particles move parallel to the motion of the wave. An example of longitudinal waves is sound waves. They can transmit their energy through liquids and gases. Okay, earthquakes produce both transverse and longitudinal waves. When seismologists study the Earth's waves, they notice that only longitudinal waves could travel through the Earth's core. With this reason, geologists believe that the Earth's core is probably made of a liquid, most probably molten iron. Okay, as you can see here, in the transverse wave, it is moving up and down in this wave's motion, which means it's going perpendicular to the wave's motion. But in a longitudinal wave, it's going the way that the wave is moving, which means it's going parallel to the wave's motion. Okay, now let's move on to the pressure wave. As you can see here, when the two tines of a tuning fork is vibrating to and fro in its mean position, it's moving the air particles surrounding it, which causes compressions and rarefactions. So when the tines move forward, it creates a region of higher pressure called compressions, and when the tines move backwards, they create a region of low pressure called rarefactions. Here you can see this is a compression and this is a rarefaction. This is a compression and this is a rarefaction. Okay. A series of compressions and rarefactions create a sound in a medium to propagate. Thus, sound is a pressure wave, longitudinal wave, and a mechanical wave. Here you can also see that when this tines vibrate in the tuning fork, here there is a higher pressure, which is the compressions, and here there is lower pressure, which is the rarefactions. This is the propagation of sound. Propagation of sound through solids. Now, ask a friend to hit one end of the table and place your ear on the other end. You'll be able to hear the sound propagating through solids such as this table. Propagation of sound through water. Place your ear on top of a bucket or a bathtub filled with water and keep a bell under the water and ring the bell without touching the walls. You'll be able to hear the sound propagating through liquids. Now, will sound travel through vacuum? When a bell is placed in a jar, sound can be heard. Now, when the air is removed from the jar with a vacuum pump, the sound is prevented by the vacuum and it cannot be heard. This shows that sound needs a medium for propagation. We'll move on to the questions now. So, the first question is, a transverse wave is transporting energy from east to west. The particles of the medium will move. I'll draw a diagram now. Okay, so the transporting energy is going from east to west like this. And it's a transverse wave, so it'll be perpendicular to the motion of the wave. So it'll go from north to south. So this is the answer. Now to the second question. A wave is transporting energy from left to right. The particles of the medium are moving back and forth in a leftward and rightward direction. This type of wave is known as, okay, so it's the energy is going from left to right like this, and the particles of the medium are moving back and forth in a leftward and rightward position. So the particles are also moving from leftward to rightward, which means it's a longitudinal wave which is parallel to the wave's motion. The waves are parallel to the wave's motion. Now to the third question. A sound wave is a mechanical wave, not an electromagnetic wave. This means that, okay, let's go to the options now. Particles of the medium move perpendicular to the direction of energy transport. This answer is not related to this question, so let's move on to the other option. Sound wave transports its energy through a vacuum. This is wrong because sound needs a medium for it to transport its energy. So this is also wrong. Let's move on to the next option. Particles of the medium regularly and repeatedly oscillate about their rest position. This cannot happen because they need to exert a force in order to oscillate. Now to the next option. A medium is required in order for sound waves to transport energy. Yes, this is right. So this is the correct answer. Now to the next question. A science fiction film depicts inhabitants of one spaceship in outer space hearing the sound of a nearby spaceship as it zooms past at high speeds. Critique the physics of this film. This will be wrong because in order for sound to be heard, there must be a medium, whereas in outer space it's made of vacuum, so there's no particles or medium. Now let's move on to the next question. The sonar device on a fishing boat uses underwater sound to locate fish. Would you expect sonar to be longitudinal or transverse wave? It's a longitudinal wave because the longitudinal waves can transport energy through liquids and gases, whereas a transverse wave needs a rigid medium for it to transport its energy, like solids. So it's a longitudinal wave. Now let's move on to the next question. A sound wave is different than a light wave in that a sound wave is, okay, let's move on to the options now. Produced by an oscillating object and light wave is not. This is wrong. Let's move on to the next option. It is not capable of traveling through a vacuum. Yes, it is not capable of traveling through vacuum. So this is the right answer. Okay, now to the next question. The to and fro motion of an object is called vibration. Now to the next question. The vibration of a tuning fork are dash in nature. They are oscillatory and periodic, which means it's C, which is both A and B. That is the correct answer. Thank you for watching my video. Please like and subscribe and comment if you liked this video. Thank you.